Morning, everybody. It is Friday morning. I am a bit tired, so you get to hear my tired voice through this video. This is Module 3. In the beginning of it, we are in Topic 1 of Module 3. Let me get this calculator out of the way for now. Topic 1 of Module 3, and that's going to be solving quadratic equations by factoring. Now, so we just got done graphing quadratic equations and figuring out how to draw the graph if given a function, and vice versa, writing an equation based off a graph, finding graph features, all of those things. And now we're going to solve quadratic equations. All right, and I've included this objective within the factoring. This isn't technically factoring, but it goes hand in hand with factoring, and it's a way to check your work while you're factoring with using the calculator. And so this objective, the first one, is to solve quadratic equations by graphing. All right, we just got done graphing, and so it's going to go, hopefully, these types of images you'll see, the parabolas will look familiar to you. Before we begin, though, I need to talk about what types of solutions you will find and what the whole process of solving a quadratic means. If you notice, like if I do number 1 here, if I'm given this quadratic function y equals negative x squared minus 4x minus 7, I notice the biggest thing I'll notice with this, it makes it quadratic, is the power of 2. It is negative x squared. And there is a theorem that we'll learn in Module 4. It's called the fundamental theorem of algebra that states that the highest power equals the number of solutions that exist for that function. And so if you notice, the highest power in this function is 2, meaning that when we solve these things, we're looking for 2 solutions, all right? Always 2 solutions. These solutions will show themselves in 3 different ways, all right? The first way is real rational solutions, meaning that they cross the x-axis as whole numbers, so they'll hit at a negative 4 or at a 0. They won't hit in between, they'll hit at a whole number. The second is real irrational solutions, meaning they still cross the x-axis, but they cross as irrational numbers, meaning they cross in between whole numbers. And if you remember, irrational means they go on forever. And then finally, the third one is that you'd find imaginary solutions. And Algebra 1 might have mentioned imaginary solutions, but this will be the first new learning that we experience later on in this module in Algebra 2, so get excited for that. Imaginary solutions, though, do not cross the x-axis, meaning that they're still a parabola, the solution still exists, but they're just imaginary because they do not cross the x-axis. Alright, so those are the 3 things that we will discover as we go through this practice, and you'll have 8 problems to try on your own, and you'll be looking for these 3 different types of solutions. Alright, I am going to do number 4 here, because number 4 will have solutions that will appear as irrational, and I want to show you what that looks like. And there's a specific button system you have to press on the calculator in order to find the solutions for irrational. So, if you would, as I'm doing number 4, please, if you want to, write out the steps that I take for the calculator. I've wrote out basic steps to find solutions if you're graphing in red up here, and that's what I'm going to follow initially, but then step 3 is a little bit more in depth. For the first step, it says, so if I was given number 4, y equals 2x squared minus 12x plus 17, and I wanted to graph the thing, I have to enter the function into y equals. So if I pull up, let me get back to the home screen. So if I pull up a calculator, I hit y equals from the home screen. It brings up this screen. I'm going to punch in my function in number 4. So we get 2x squared minus 12x plus 17. Next step is to hit, if I scroll up, it says to hit graph. So I'm going to hit graph, and it'll bring up a picture of a parabola, if you notice. And if you notice it's a little skinnier than the regular one because the a term was 2, so it's being multiplied by 2. At this point, if your graph doesn't look like this, you would hit zoom. Zoom brings up a whole bunch of options for the calculator. You can do zoom standard, you could zoom out, you could zoom in, you could do zoom stat, which we've worked with, but if it doesn't look like mine right now, hit zoom and then 6, and that'll bring up the original window. Now at this point, if I want to find the solutions, again, solutions exist on the x-axis. It's where they cross the x-axis, that's why they're called x-intercepts. They're also called solutions, zeros, and roots as well. If I want to find them, I'm going to hit second trace, and then I'm going to go to the 0 option because I'm looking for the zeros. or the solutions. I'm going to hit enter, and if you notice, there's two of them. There's two different locations where this crosses the x-axis. It's going to ask for a left bound, so I'm going to move my cursor. If you notice, there it is. It was further to the left and out of the screen, so I moved it to the right. There is my cursor. I'm going to look for this 0 first. So I'm going to go down close to the 0. It asks for a left bound, so I have to put it left of where it crosses the x-axis, and I'm going to hit enter. Then I'm going to go to the right of where it crosses the x-axis for the right bound and hit enter, and then it's going to say guess, and I'm going to hit enter one more time. This 0, if you notice, is irrational, meaning that it goes on, the decimal goes on forever. So the first root is an irrational 2.2928932. I'm going to round to the 10th place, so 2 decimal places. Put 2.29 as my first solution in X. Now I'm going to find the other one. So I hit second, trace, 0, the second option. And I'm going to move over, and left bound now is below the x-axis, but it's still left of the other root. I hit enter, move up to the right bound above the x-axis, hit enter, and then I'm going to guess at that spot. The other 0 is 3.71. The 7 rounds up the 0 to a 1. So the other 0 then that we have found is 3.71. Let me clean that up a bit. Things I need to do, I need to include what type it is, and it is a real irrational, meaning that it does hit the x-axis, so that makes it real. Because it hits the x-axis, it is a real solution. And then it's irrational because it is a decimal that goes on forever. I have just noticed that I typed this in the wrong place. Let's do a little switch here. Wait for it. Where'd you go? There. I'm answering number 4. So it's real because it hits the x-axis, and it's irrational because the decimals go on forever. I've rounded the decimals, but they do go on forever. What I do for this problem is to draw a rough sketch based off of the image on the calculator. All right? And so we need to find the vertex, and this is based off of drawing from Module 2. But in order to find the vertex on a calculator, I hit second, trace, and if you noticed, it was a minimum, so I need to find the minimum value. And I'm going to go to the left bound, hit enter, the right bound, hit enter, and then I'm going to guess. And that minimum is at 3. These zeros just mean it's at 3, the closest estimate. So 3, -1 is my vertex. Calculator, I found the vertex at 3, -1, so I plotted that on the graph, and now I'm going to use the step pattern. And if you notice, my A term is 2, so I'll write that just to help me see that. The A term is 2, so I'm going to go over 1 up 2, over 1 up 2, to both sides, over 1 up 2, over 1 up 6, 1, 2, 3, 4, 5, 6, and over 1 up 6, 1, 2, 3, 4, 5, 6. There is a rough sketch of my parabola. And if you notice, x equals 2.29 is right about where it crosses the x-axis right here. And then x equals 3.71 is right about where it crosses right there. And at this point, I have done everything. I have used my calculator to graph the function. I have used the calculation tool within the calculator to find the x-intercepts where they cross the x-axis. I've determined that they were real and irrational. And then I drew a rough sketch based off of the vertex and the step pattern. So at this point, I would ask that you go ahead and try number 3 on your own. All right, please try number 3 on your own. Pause the video and then unpause the video to check your work with mine. All right, at this point, you should have paused the video and tried to graph this one on your own. Here's a picture of the graph. If you notice as well, it's a negative parabola, so it has a maximum. And it crosses the x-axis in 2 places, one at 1, 2, 3, 4, 5, 6, so -6, and one at 2. All right, I found those using the calculation feature of finding zeros, and at this point my screen is at finding the maximum, all right, or the vertex. So I wrote my answers, x equals -6 and -2, meaning they cross the x-axis at -6 and -2. And because they cross the x-axis, that means they are real. And because they cross at whole numbers, that means they're rational. So this type of solutions is real/rational. All right, and now I'm going to draw a rough sketch of it. So I'm going to plot my vertex, -4, 2, up to here. And the a term in this case is negative 1/2. So it used to be over 1, in this case down 1, and then over 1, down 3. But because it's 1/2, I'm dividing my down motion by 2 each time. So I'm going to go over 1, down 1/2. So over 1, down 1/2. Then over 1, down 3/2. So 1, 2, 3. And I'm going to do the same thing over 1, down 1/2. And over 1, down 3/2. 1, 2, 3. And if you notice, because I did the step pattern exactly because of the a term multiplier, this does indeed cross my x-axis at -6, -2. So at this point, I have done everything that I asked of you. I asked that you draw a rough sketch, that you find the solutions with your graphing calculator, and you label the solutions real rational in this case. If your work doesn't look like mine, please raise your hand or check with a neighbor, and I'll come by and check it as well. Thank you.